How you deal with?
What is going on, everybody? It's your boy Average Leader here with another video. Today we're tackling Google's second most asked question, maximum points you can obtain from cards, number 1423 on Leetcode. Before we start, if you guys can go ahead and hit that subscribe and like button, that would mean the world to me. It helps my channel out a ton by giving it more exposure to people that don't know me. And with that all out of the way, here we go. So the problem description says, there are several cards arranged in a row, and each card has an associated number of points. The points are given in the integer array card points, okay? So this has all the points. In one step, you can take one card from the beginning or from the end of the row. You have to take exactly k cards. Okay, so this is very important information. Your score is the sum of the points of the cards you have taken. Given the integer array card points and the integer k, return the maximum score you can obtain. Okay, cool. So let's work through an example really quick. So here's the example that was given to us from Leetcode, and I wrote down the key points on the side right here. So looking at number 1, in one step you can take one card from the beginning or the end. So what does that really mean? Well, that means in one step we can take a card from here in the beginning or here at the end. And for sake of example, let's just say we take a card from the beginning. This is going to be our first step. Okay, we can only take up to k cards, so we only have 3 cards to take. But now when we take this first card away, that means our beginning has shifted to this, to the 2. Now, we can either take a card from the beginning, which is here, or the end. And let's just say, for sake of example, we're going to take this card. So this will be our second card. Now we have one last card to take, but also our end has shifted from here, to the 6. And now let's take one more card away, and let's just say we'll take the 6. So now the end has shifted up here, and this will be our third card that we take. So in 3 steps, we can take these 3, or we have chosen to take these 3 cards. Now we need to choose k cards in a way where we are returning the maximum score. So in this particular example, we see that the maximum score from k cards, from 3 cards, comes from the last 3 over here, 5, 6, and 1, because this will give us a sum of 12. There's no other sum that can be made from any beginning or end card combination that'll beat 12 in this case. With that out of the way, how can we solve this problem? Well, the big key here is understanding that we have to use a sliding window. And to me, this problem really screamed sliding window because of these 2 things. A sliding window is often used when we're looking for a subrange in an array or a string. And in our particular situation, we have a subrange. It's not going to be given to us very clearly. Like, the question is never going to say, here, use a subrange, or like, take the subrange. But in our case, we have up to k cards that we can take. So in this particular example, our subrange is any range that has k elements. So this could be a subrange, or this could be a subrange. But remember, look at this right here, this example up here, we picked this card and these cards. So our subrange is 6, 1, 1 really, right? So we have a subrange of k at all times. So we have this criteria, number 1. And now, second criteria is we're looking for a subrange in an array where we're looking for some type of global maximum or minimum. Okay, and what does a global maximum consist of? Well, we can have a longest value where if we're given an array or a string of n numbers, we're looking for like the longest possible value in that array. We can have the smallest number where if we had an array of n, we're only looking for just the smallest range of numbers that we can get. We're looking for the minimum value or a maximum value. So basically, if we're given an array here, we're looking for the minimum value. So in this case, it's 1, or a minimum sum, or a minimum difference, or something like that, or a maximum value, maximum sum, maximum difference, whatever it is. And the last criteria is we're looking for a k size value. So in our problem description, this really screams use a sliding window approach because we have a subrange, which is a size of k, and we're looking for a maximum score, and we're also looking for a maximum score using k cards. So we're really hitting the nail with these criteria here. So what would a sliding window look like? A sliding window is really when you have a left boundary and a right boundary, and we're slowly shifting one or the other until we have met some form of criteria. Okay, so now in our situation, we're looking for the max sum using 3 cards, or k cards, but in this example we have 3. So let's just make a sliding window of everything that contains the beginning and the end, which will always have 3 cards. So in the beginning, we can have this window, right? And our sum here is 6. Okay, so let's make a note of that as well. Our max sum so far is 6. Now let's just shift our left boundary to the end and our right boundary backwards 1 space. So now look, our subarray is 1, 1, 2. Now this sum is 4 here. But now this sum isn't greater than our last possible sum, which is 6. So our max sum is still going to be 6. Now let's shift our right boundary over 1 more time, and let's shift our left boundary back 1 more time. So now our subarray is 6, 1, 1. We have a sum of 8 here. So great, now our max sum is 8. Finally, let's shift our left boundary back 1 more time, and our right boundary back 1 more time. And in this case, our sum is 12. And this seems to be the max sum we've gotten so far. So look, max sum is 12. This is the answer to that example in the Leetcode problem. So we've gotten the maximum amount of points from these cards. Let's go through another example. So in this example, we can see that our max sum is obtained when we pick this card, and this card, with a sum of 85 plus 83 will give us a sum of 268. So let's just make another sliding window with k cards and find our max sum. We'll start our window with the first k cards. And these 3 cards will give us a sum of 159. So our max sum off the bat will be 159. Now let's shift our right boundary back 1 and our left boundary back 1. So now our subarray is 83, 150, and the sum from this will be, looks like 233. So our max sum is now 233. Awesome, we have a bigger sum, perfect. So now let's shift our left boundary back 1 and our right boundary back 1, and now our subarray is 85, 83, and 100, and this will give us a sum of 268. Perfect, that is greater than 233, so our max sum will be 268. And finally, let's shift our left boundary back 1 more time and our right boundary back 1 more time, and this subarray will give us a sum of 185. This isn't greater than our max sum, so let's not change our max sum, and we'll finally just return our max sum here. Awesome. So sliding window technique, very useful, really good to know. And let's go ahead and implement this for our problem. All right, so first things first, what are we trying to return? Well, we are trying to return a max sum. So we'll go ahead and initialize that. And we know that this will be the thing that we will return. Okay, and now let's start by getting the sum of the first k elements. So I can do that with a quick for loop, where int I equals 0, I is less than card points dot length I plus plus, and all we're going to do is max sum. Oh, actually, we don't want to go all the way to card points dot length. We just want to go to k. So max sum plus equals card points at index I. Okay, so now we have an initial max sum. Okay, now to do a sliding window, it's really easy because you just need to simulate the addition and the subtraction of elements once, and we'll just put that in a while loop. So it'll just keep doing that action until the while condition is met. So what are we really trying to do? So let me just do a quick example to show you before we get into it. So originally, we are at this subarray with this window, where we have the sum between these values, and we basically have our left pointer here and our right pointer here. That's where we should start. So let me go ahead and do that. Int left equals 0, int right equals, well, this right is just k minus 1, because here we're looking for the kth value, or like we're looking for k cards, we're using k cards. Since we have 3 cards, this is the second index, so k minus 1. What we will do is, so the next iteration would be where we shift the right back 1, and we also shift the left back 1. But when we do that, the left pointer comes on to the end of the array, this part of the array. So now our subarray is 1, 1, 2. So that is going to be the next iteration. Let's keep that in mind. And what are we doing here? So when we move our left pointer back 1, we're going to add this number, and we're going to subtract this number before we shift our right pointer over. Okay, so in this case, we're going to need some type of loop. So I'll start with a while loop. And what is going to be the condition that's going to be used to stop our while loop? Well, the last sum we're going to take is when the left pointer is in the length minus k spot, or in this case, where it's at 5, right? So k is 3, the length here is 7. So when we're at the 0, 1, 2, 3, the 4th index, that's when we're going to want to stop. We just want to get this sum and then stop. So what we're going to do is we're going to do while left does not equal card points dot length minus 1. We'll just keep doing our thing. So what are we doing from the first iteration to the second iteration? Well, first we're decrementing our left pointer in hopes to get it back, wrap around to the end of the array. And since the first decrement will be in the negatives, we're at the 0th index. If we decrement, it will be -1. All we'll do is if left is less than 0, we'll just add the length of the array to the left pointer. So plus equals card points dot length. Okay, so now the left is here, right? And what are we going to want to do to the sum? We're trying to get the sum of this value and these two values, right? So what are we going to do? We're going to add this value to our sum. So what we're also going to do, where are we going to hold this sum? I'm going to hold it in this variable called temp sum. And what is our temp sum going to initially equal? Well, since we already have another sum that just holds the first 3 values sum, we'll just set our temp sum equal to our original sum that we calculated, and we'll just add and subtract from this temp variable. So when we shift our left pointer back, we're going to add that left pointer's value to temp sum. So it'll look something like this. Awesome. Now we know we're going to decrement our right pointer back 1, but right before we do that, we need to get rid of our current Windows value that the right pointer is pointing to. So we're going to subtract that value that the right pointer is pointing to from our temp sum. And then we're going to decrement our right pointer. And the last thing we're going to do, since we're returning max sum, and max sum is going to represent the maximum sum of our array, we're going to see if our max sum that we've calculated is greater than our temp sum. If our temp sum is greater than our max sum, we're going to reset our max sum to be what temp sum equals. And the easiest way we can do that is we'll just set max sum equals math.max of max sum and temp sum. So that way we get the maximum value at all times. So this is it, guys. Very, very straightforward. Usually these sliding windows are like pretty quick. So let's go ahead and run this.
They ask you how you are, you just have to say that you're fine when you're not really.
Oh, okay. I guess we forgot something. Oh, it's this, guys. I'm sorry. I even said we're trying to go to card points dot length minus k, not -1. So that's my bad, guys. Awesome. So we have that. That works. Let's go ahead and submit this. Okay, good. Faster than 100%, 1 millisecond. Okay, awesome. So now here's one last thing we can do to clean up this code just a tad bit. So we start at 0, and then when we subtract 1 from it, we're adding our card points.length. So we're basically setting our very first left pointer back to the last element in our array. So a very quick, fix to this. This is kind of like an unnecessary if. If we want to clean it up, all we'd have to do is initialize our left pointer to card points.length, and we can get rid of this. And then our first decrement will take us to the card points.length -1 value, which is this index. So let's just run that again. Make sure that works out. Perfect. Submit. Bingo. All right, that works. So what's the runtime for this? Runtime and space-time complexity. Well, one of the greatest things about a sliding window is it usually will run an O of n worst case time. So what is like the worst case here? I think the worst case is when we have the length of the array equals k, or when k equals the length of our array. So let's just say k equals 7 here. Then we would, our initial for loop would grab the sum of all elements, right? And then our left and right pointers would be here and here. And then the next iteration, we would shift the left pointer back and the right pointer back as well. So basically, both pointers would iterate through the entire array one more time until the condition of, while left doesn't equal card points.length minus k. Well, if our length is 7 and our k is also 7, until our left pointer hits 0, this would keep going, right? So our left pointer would hit 0, and then this would stop. So basically, we'd iterate through the array twice, once to get the sum, and then once until our left pointer hits our 0. So that would be O of 2n. That simplifies to O of n. So our worst case runtime complexity is O of n. And our space-time is O of 1, since we're not really creating extra storage, extra space, other than these little variables right here. So that's nothing in the grand scheme of things. So yeah, guys, that's how you do this problem. Let me know how I did. Let me know if everything made sense. And if there's anything I could improve on. And also, let me know in the comments below if there's any other problem you'd like to see me do. I absolutely love crushing these problems, and I love teaching you guys how to do these problems. And it helps me a ton in the process as well. And finally, guys, just give this video a like and subscribe if you found any value from this video. And yeah, I'll see you guys next time.